This is example 1. It says 2 to the x is equal to 60. Solve for x. And so I know that 2 to the 5th power is 32. Right, that's 2 times 2 times 2 times 2 times 2 is 32. And I know that 2 to the 6th power is 64. And so here x must be some number between 5 and 6. The exponent has to be a decimal 5 point something between 5 and 6. I could go through a lot of trial and error. I could try 5.1, 5.2, 5.3, and then eventually I could try things like 5.81, 5.82, 5.83, and so on. That's going to take a lot of work, a lot of time. And so how can we find a better way to solve for x? So we'll take 2 to the x equals 60, and I'm allowed to take the logarithm of both sides of the equation. And it doesn't matter if I take the natural logarithm or the common logarithm. It's not going to make any difference. I'll take the common logarithm. So I'm going to take the common log of 2 to the x is equal to the common log of 60. So again, whatever I do to one side, I'm allowed to do to the other, and that still gives me an equivalent equation. Right? So this is equivalent to the original equation. Taking the logarithm on the left allows me to bring the exponent out as a multiplier. So I can rewrite this as x common log 2 is equal to common log 60. And now I have the x out of the exponent. And so now I can solve for x by dividing by log 2 on both sides. They cancel over here. And we're left with x is equal to log 60 divided by log 2. And so we'll use our calculator for that. So now I can easily find the answer. I can take the log of 60, close parentheses, divided by the log of 2, close parentheses, and we get 5.907. 5.907. And so the solution is that 2 to the 5.907 power is what is equal to 60. And we can check that answer. We can do 2 to the 5.907 power, and we get 60.00455. And so we did round our answer, so that's why it's not exactly correct, but it's very close. This is example 2. It says 4 to the x plus 2 power is equal to 36. And so we'll want to do the same thing that we did last time. I'll start by taking the logarithm of both sides. It could be common log or natural log, it makes no difference. Maybe this time I'll use the natural log. I can take the natural log of 4 to the x plus 2 power is equal to the natural log of 36. And now the same rule applies. Now that I have a logarithm, I can bring the exponent out as a multiplier. So the entire x plus 2 comes out as a multiplier. And now I can divide out the natural log of 4 on both sides. These cancel, and we get x plus 2 is equal to the natural log of 36 divided by the natural log of 4. Whatever you do, do not try to reduce this fraction. This is the natural log of 36 and the natural log of 4. This does not mean natural log times 36 and natural log times 4. That's not what it means. And so this does not reduce. Right? We have to leave it this way. To continue solving now for x, I'll subtract 2 from both sides. These cancel, and we get x is equal to the natural log of 36 divided by the natural log of 4 minus 2. And so now we can use our calculator to solve for x. We'll take the natural log of 36, close parentheses, divided by the natural log of 4, close parentheses, and press equals, and we get 2.585. 2.585. And I still need to subtract 2. And so when I subtract 2, we will get x is equal to 0.585. Now it's always a good idea to check your answer. We should plug this back in for x. So 4 to the 0.585, which is x, plus 2 should be equal to 36. And so we'll add these together first. 4 to the 2.585 power should be equal to 36. And we can use our calculator to find 4 to the 2.585 power. And we get 36.00187. So we did round our answer, so it's not exactly right, but it's very close. This is example 3. It says 4 to the 2x power is equal to 12 to the x plus 1 power, and solve for x. And so we will take the log of both sides, and again, it doesn't matter if you use common logarithm or natural logarithm, makes no difference. I'll use natural logarithm. Natural log of 4 to the 2x power is equal to the natural log of 12 to the x plus 1 power. And now this problem is a little different because we have x's on both sides. So now that I have logarithms, I can bring the exponents out as multipliers. We will get 2x times the natural logarithm of 4, right? 2x comes out, equals x plus 1 in parentheses. All of this comes out as a multiplier. X plus 1 times the natural logarithm of 12. Now, the problem is we have x on both sides. Our strategy is to get the x's all to one side of the equal sign and then isolate the x so that we can solve the equation. And so anytime you see a problem like this, you should be thinking distributing. You should be thinking that you need to distribute. So the natural logarithm of 12 distributes into the parentheses. We'll have 2x ln 4 is equal to x ln 12 plus 1 times ln 12, which is just ln 12. Now the x is no longer in parentheses, neither is this one. My goal now is to get the terms that have x in them to the same side, so I'll subtract x ln 12 from both sides, subtract x ln 12, and we'll get 2x ln 4 minus x ln 12. These canceled, and this will be equal to ln 12. Now I have both terms with the x. They're on the same side of the equal sign. X is being multiplied by 2 and ln 4. It's being multiplied here by ln 12. That means I can factor the x out. So my goal is to get the x as a single x, right? I have two x's now. When I factor it out, I'll have a single x, 2 ln 4 minus ln 12 is equal to ln 12. So now I have the x isolated. I can solve for x now by dividing by everything in parentheses. 2 ln 4 minus ln 12. Same thing over here. Divide by 2 ln 4 minus ln 12. All of this cancels, and we get x is equal to the natural logarithm of 12 divided by 2 times the natural logarithm of 4 minus the natural logarithm of 12. And so we can plug this into our calculator now. If you go with your calculator, you should be able to type all of this in at once. You will type in the natural logarithm of 12 divided by, and I want to make sure that I divide by everything in the denominator. So I got to make sure that I put this in parentheses in my calculator, right? Because I'm dividing by all of this. So I'm going to open parentheses. Oh, and I forgot to close my parentheses after the logarithm natural log 12. So I can't do that. I got to make sure I do natural log 12, and then I have to close those parentheses, and then divide by, open parentheses, 2 times the natural logarithm of 4, close the parentheses on the natural logarithm, minus the natural logarithm of 12, close parentheses on the natural logarithm, close parentheses for the denominator, and then press equals. And we get that x is equal to 8.638. Always a good idea to check our answer. So let's plug this value back into the original equation. We have 4 to the 2 times x, which is 8.638, close parentheses, equals 12 to the x, which again is 8.638, plus 1 power. And so let's work out the exponents first. 4 to the 2 times 8.638, which is 17.276. 17.276 is equal to 12, and now we're just adding 1, so it's going to be 9.638. And so when we type in these exponentials into our calculator, they should be equal. So we'll do the 4 first. It's 4 to the 17.276 power, and we get 2.519. And then over here we'll have 12 to the 9.638 power, and we get 2.519 again. And these are actually in scientific notation. The E10 means that it's 2.519 times 10 to the 10th power, and times 10 to the 10th power, right? So both answers were E10, which means the power of 10. And so what that means is the decimal point actually belongs 10 places to the right in each one of these answers. But both answers are the same. That's what's important. This is example 4. It says 10 to the 2x power is equal to 1,450. And so the base over here is already 10. I don't want to use the natural log where the base would be e. If the base is already 10, it makes the most sense that I use the common logarithm. So I want to take the common logarithm of both sides. Log of 10 to the 2x power equals the common log of 1450. Now the exponent comes out as a multiplier. This would be 2x. Common log 10 is equal to common log 1450. Now the main reason that I chose the common logarithm here is because log base 10 of 10, the log base 10 of 10, which is the common logarithm, equals some number. I can rewrite this as an exponential. This means 10 to the x power is equal to 10. And what is x? That has to be 1. X is 1. And so the common log of 10 is 1. And 1 times 2x is just 2x. So the common log of 10 cancels. This cancels. Right? And so again, that's why it was important that I chose the common logarithm, not the natural logarithm. And so now I get 2x, because common log 10 cancels, equals the common logarithm of 1450. Now I want to solve for x. I'll divide by 2 on both sides. 2's cancel. X is equal to the logarithm of 1450 divided by 2. So this I can type into my calculator. And so we get the log of 1450, close parentheses, divided by 2, equals 1.581. 1.581. And again, it wouldn't hurt for us to check our answer. So we'll plug in 1.581 back in for x. We have 10 to the 2 times 1.581 power is equal to 1,450. And so 10 to the, let's multiply first, 2 times 1.581 is 3.162. This should be equal to 1,450. So now we can work out the exponent. 10 to the 3.162 power is 1,452. And of course, because we rounded our answer is not exactly right, but it's very close. This is example 5. It says e to the negative 3x power is equal to 0.725. And so I want to take a logarithm of both sides, and I want to make sure I use the natural logarithm because the base here is already e. It wouldn't make a lot of sense for me to use the common logarithm. I'll use common logarithm if the base is already 10. So I'll take the natural log of both sides. Natural log of e to the negative 3x is equal to the natural log of 0.725. Logarithm allows me to bring the exponent out as a multiplier, so I get negative 3x times the natural logarithm of e is equal to the natural logarithm of 0.725. And so the natural logarithm of e, remember that the natural logarithm means log base e. So natural logarithm is log base e of e is equal to x. You can rewrite this as an exponential. E is the base, x is the exponent, and e is the power, or the answer. And so what power do I raise e to get e? X must be 1. X must be 1. And so the natural logarithm of e is 1. And so the natural logarithm of e cancels because 1 times negative 3x is just negative 3x. That cancels. And now I can solve for x by dividing both sides by negative 3. Negative 3 cancels. We get x is equal to the natural log of 0.725 divided by negative 3. And so now we can work that out in our calculator. We'll take the natural log of 0.725, close parentheses, divided by negative 3 equals, and we get 0.107. 0.107. And so we should check our answer. Let's plug this back in for x. E to the negative 3 times 0.107 should be equal to 0.725. And so we'll multiply out the exponent first. We'll take negative 3 times 0.107, which is a negative 0.321. Negative 0.321. This should be equal to 0.725. Now we'll take e to that power. So we'll take e to the negative 0.321 power, and I get 0.725. And so that's how we know we have the right answer. This is example 6. It says 36 equals 45 times the quantity of 1 minus e to the x over 2 power. And so x is in the exponent, right? X is in the exponent. We can get the x out of the exponent by using the logarithm. But before I can do that, I need to get e to the x over 2 power all by itself, right? I need that to be the only thing on this side of the equal sign before I can take the natural logarithm. So I need to start by getting rid of 45 and getting rid of 1. Also getting rid of the negative, and then I'll be able to take the natural logarithm of both sides. So I'm going to start by dividing both sides by 45. These will cancel. You get 36 over 45 is equal to 1 minus e to the x over 2 power. And now I want to get rid of the 1, and so I'm going to subtract 1 from both sides so that these will cancel. And over here I'm going to be left with negative e to the x over 2 power. Over here, I'm going to have this fraction minus 1. This fraction reduces. These are both divisible by 9. This is 4/5. So I'm going to write this as 4/5 minus 1. 4/5 minus 1. And now I want to get rid of the negative. I can get rid of the negative by multiplying everything on this side by negative 1, multiplying everything on this side by negative 1. That will cause the negative times the negative to be a positive. So I'll get positive e to the x over 2 power. And over here I have to distribute the negative, so the 1 becomes positive, and the 4/5 becomes negative. Okay. And while I'm at it, 1 minus 4/5 is 1/5, because 1 is 5/5, right? 1 is 5/5, that's 1. 5/5 minus 4/5 is 1/5. And this will be equal to e to the x over 2 power. Now I can take the natural logarithm of both sides. So that's what I'm going to do. We'll get the natural logarithm of 1/5 is equal to the natural logarithm of e to the x over 2 power. Now I can bring the exponent out as a multiplier, and so we'll have natural log of 1/5 is equal to x over 2 times ln e. The natural logarithm of e is 1, and so that cancels. That cancels. And so we get ln 1/5 is equal to x over 2. I want to solve for x, so I multiply both sides by 2. These cancel, and we get x equals 2 ln 1/5. Okay. And so now I can plug this into my calculator and solve for x. So x is equal to 2 times the natural logarithm of 1/5, close parentheses. We get negative 3.219. Negative 3.219.